All right, good morning. What we're going to talk about this morning is, initially, when first class started, I said I was going to teach you how to, if you're going to you're going to do a small concrete project, sometimes what's more convenient is to, you've got a few 5-gallon buckets, is to be able to go get so many buckets of gravel, so many buckets of sand, and so many buckets of your concrete, and so many buckets of water. If you can go out and do that and gather them up, sometimes that's easier than trying to have a whole bunch of sand delivered and just things like that for smaller projects. So I'm going to show you how to figure that out. First thing you got to understand is you hear people talking about parts. Now you'll see a recipe of something and they'll say like, well, you got 1 part of this, 2 parts flour, 1 part oil, 3 parts this. You ever kind of wonder how that works? If you're talking about like if it's got 1 part this and 1 part that, there's only 2 parts, so it's like half this and half that. But sometimes it gets more complicated. Now, an example, like say, parts. The parts and quality is you're looking at like how much of something that you're going to use for something, okay, and how much volume or how much weight that is, okay, and that is directly correlated to how big the volume is, how much the total weight or volume of something is, then how many parts are of that. Here's just an example. Okay, let's say we've got a 9-inch pizza. And just for the math, we're going to say that it weighs 10 pounds. Okay, I'm just making off of that big great pizza, but it's 9 inches and weighs 10 pounds. Okay, well, it's a 9-inch piece and it weighs 10 pounds. Okay, so the total volume and weight of this pizza is what?
10 pounds.
It's 10 pounds. So if it had just 1 part, that part would weigh 10 pounds. If we had 2 parts, what would a part weigh?
5 pounds.
A part would weigh 5 pounds. So it's still a part, but the pounds did not change. But as we added more parts, the volume or the weight of the part changed, correct? Now let's say we cut it again. Now we have 4 parts. So what would a part weigh?
2.5 pounds.
Part would weigh 2.5 pounds. Okay, now, we're going to say this was a 10-pound pizza. I'm going to say this is a 20-pound pizza. Now it's also a different, it's 10 inches, okay? So the inches and everything really didn't matter how round it is, or the size, the shape doesn't matter how much the part weighs or what's the total volume of that pizza. Because this could be a 10-pound pizza also. But we got another pizza that's a 10-inch pizza that weighs 20 pounds. Now, 1 part of this pizza would weigh what?
20.
Okay, I thought a part was 10. Okay? It changed, didn't it?
Yeah, it's
Because the volume, the total volume of what we're dealing with, or the weight, changed. Like I say, the size of a part is directly correlated with the total volume and or the number of parts. So a part for this and a part for this is different because the total volume is different. So now for this, what would 2 parts be?
2.5.
So a part is 10 pounds. Now what if I did it like this? Okay, we're going to say that's what? That's 8 equal, we're going to say they're 8 equal parts. What does a part weigh?
2.5
Divided into 20.
How did you get that answer?
8 divided by 20.
Divided by 20.
8 divided 20 by 8.
20
Divided.
divided by 1, 2, 3, 4, 5, 6, 7, 8. Okay? Everybody paying attention? Some of you not looking at me, haven't looked at me the whole time. Okay? 20. So we're gonna say this is all, and everything's the same way. We're just gonna say that it's a total, we're gonna say that it's just a cheese pizza. So all the parts are the same, okay? It's eight parts of just that. Now let's do this. Let's say that with this pizza, we're gonna say we made one. Those are pepperoni, those X's. Now these that are the same are cheese. Now, we have so many pounds, if we add them together, we got so many pounds of pepperoni pizza, and we have so many pounds of cheese, okay? So how would we figure out how many pounds of pepperoni then how many pounds of cheese? How would we figure that out?
Divide 20 by 8 and 3 by
Then
20.
divide your pepperoni by
And subtract it.
20 and then take 3.
Okay, we've determined how much, on here, how much is a part weigh?
2.5.
Okay, the pepperoni, 2.5 times 3, right? And the cheese, 2.5 times what? 5. Okay, we're not gonna do the math on that. But you can tell exactly what they weigh. Now, that's the way things work when you start dealing with anything. You start dealing with a volume, whether it's water, whether it's a liquid, whether it's whether it's a solid. Certain things have certain parts, and you may start out building something. Say an example, maybe you have a concrete recipe. Maybe it's so many parts gravel, so many parts sand, so many parts concrete. So if we said something had, okay, this would be the same thing. I wrote up here a pound candy bar. It would be the same thing. No matter what the shape was, if I added, the more parts I add, if I'm making them equal, you're just going to divide the number of parts times the total mass or the total volume of whatever you're dealing with. Whether it's a candy bar, whether it's pizza, or whether it's a concrete slab that you're getting ready to pour. Now, if we were doing something, let's say, I'm not going to get the concrete right yet. Let's say that we were going to be building what's something we could build? We're making a recipe.
Making a round table.
We're going to make
Brown cake.
cake. All right, we'll make a cake. We'll make a big cake. We're going to make a cake. This cake, how much is the cake going to weigh, Bill? Needs to be big. 20 pounds, that's what I'm talking about. Okay.
Get mad, huh?
That's a big cake, plus the math will be easy. All right, now, we got a big old fat cake we're gonna make. Now, let's give me some things that go in a cake.
Flour.
Flour,
Eggs.
eggs, milk, sugar. I just say sugar, give me one more thing goes in there.
Some nuts.
Hey, ice, all right, we'll say, and frosting.
Yeah, frosting.
That's how you're gonna say it. Gotta have frosting. I ain't making a cake without no frosting.
Y'all boys so know how to make cakes.
Boy, no, man, that's right. Y'all pass this cake, y'all can at least go learn to bake. Okay. All right, now this is not gonna be important, but we're just gonna kind of figure this out. Now, when we start looking at parts, it's based on, we're gonna pretend we're doing all this by weight. Okay, we're not gonna say 2 eggs. We're gonna kind of weigh everything. Okay, the bulk of that weight is probably gonna be what? Maybe flour? So we're gonna say that it is, we're gonna say that it's, we're gonna say it's gonna be 7.5 parts flour. We're gonna say it's gonna be 2 parts eggs, it's gonna be 3 parts milk, it's gonna be 4 parts sugar,
Yeah.
sugar, and the frosting, let's get a number we don't have on here, a lot of frosting on that bad boy, 5 parts. Who said 6? You're gonna have diabetes, man. All right. 5 parts frosting. Now, that's a recipe, and that's the way recipes come sometimes. Maybe not for a cake, but maybe if you're mixing something, you know, you're gonna be mixing some poison or something. Maybe you got 2 types of poison, something you're mixing to work on the side of a highway. It's gonna say like 4 parts water, 3 parts of this, you know, this chemical, 2 parts of this chemical, 3 parts of that chemical. And you gotta figure out, how do I figure that all out? Because, you know, because it's gonna be different, because you might be mixing it in a 50-gallon drum on a big tractor, but you might be mixing it up on one of them backpack. Might be a 5-gallon drum. So no matter, it's still got the same amount of parts, right? But the parts are gonna change based on the total volume. Now, we came up with a total volume. Our total volume of this cake was what?
20 pounds.
20 pounds. Now, we gotta figure out how many pounds of flour, how many pounds of eggs, how many pounds of milk, how many pounds of sugar, how many pounds of frosting that goes into this cake. So, what would be the next step we would need to do?
Divide each one of them by 20.
Do what?
We divide each one of them into 20.
Okay, each one of them into 20? Well, no.
But you gotta get it all in like units first. You write it down.
We gotta figure out what. What did we do a while ago when we had the pizza? What did we have to figure out? Because it changed when we had 2 pieces of pizza, then we had 8 pieces of pizza, remember? So we gotta get our total number of what? Of parts.
Right.
So we gotta add the parts together. So 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, right? So we have 21 parts. We don't care what they are. It's irrelevant what they are at this time. We just have to know how many parts we got, because we got to know how much volume is in a part. Because we know if we had 1 part, it would be 20 pounds. Okay? So, because 20 divided by 1 is 20. So how do we figure out how much a part weighs? 20 divided by
No
smartest group of kids I've ever seen. Okay, so 20 divided by 21 equals what?
1.05.
One more time.
1.05.
It's 1 point.
0.95.
Thank you.
0.95.
0.95. I knew it was gonna be. They can't be 1 because that's small. So 0.95. So each one of them parts weigh 0.95. It doesn't matter what the part is, whether it's flour, eggs, milk, sugar, or frosting. It's a part. Each part weighs 0.95 of a pound. Whether it's sand, gravel, concrete, water, if we're dealing with a part, it doesn't matter what it is. Doesn't matter how thick it is. Don't matter if one's heavier than the other. It's a part is a part is a part. We need to know how much a part weighs. So, I'm gonna go back this way. So I'm gonna say pounds of each. So, how do we know how much flour to put in this? Say it a little louder.
Times 7 by 0.95.
Outstanding. Your number of parts times the weight of your parts. So 7 times 0.95 equals what?
6.65.
6.65. All right, y'all continue doing the math all the way down. Need to have a giving everybody in here a calculator. I'm gonna point at you. Gotta get good, get ready. All right, yeah, you looking at me. What's the next one?
How you get that? That's 16.5 over there at the top of that.
And 2 times 0.95, 3 times 0.95, 4 times 0.95, 5 times 0.95. Make sure you understand this concept, because we're going to turn this cake into concrete. That's usually the way mine turn out anyway.
1.9, the eggs is 1.9.
Eggs is 1.90. Okay, what's the milk? Give me the milk, Lyndon.
2.85.
2.85. I know it's Friday, but y'all need to pick up the pace. Toby, how much sugar? 3.80. Okay, when you guys give me a weight or something, give me the last number too. 0.80.
4.75.
What?
4.75.
Okay. Does everybody understand that? So whatever you're dealing with, whether it's concrete, whether it's a cake, whether it's a bunch of liquid, you're dealing with fluids or whatever, got to find out what's the total amount. If it's gallons, you're dealing with gallons, what's the total amount of gallons? Then how many parts go in it? How many parts you got? Divide that parts by, if you got a 5-gallon tank, you got 5 parts, each part's a gallon. You got 10 parts, it's 0.5, okay? Your total volume divided by the number of parts. Then then multiply that part, then look at your item, whatever it is, whether it's poison or water or whatever, or flour, eggs, or concrete or gravel, however many parts of that that's in the recipe or the formula, that times whatever the weight of the part is equals how much you need, okay? All right. Okay, let's look at this. All right, everybody knows how to do this. Give me the volume in cubic feet of this concrete slab. This concrete slab is going to be it is going to be 5 feet deep. It's going to be 20 feet long. And it's going to be 4 inches. These are feet. It's going to be 4 inches thick. Okay, don't forget when you do that, convert your inches to feet. How do you do that?
About 12.
4 divided by 12, which is going to be what? 0.33. So 0.33.
Times 100.
So everybody got that? We can do that real quick, right? 5 times 20 equals what, 100?
It's 33.
Times 0.33
Uh-huh.
equals 33, right?
33.
Well, this is 33
Cubic yard.
feet cubed. Okay, we're not all about yards, but we're going to keep it in feet. Okay, for these little small projects, we're going to keep them in feet to keep them simple because we're not ordering a truck or anything like
You
that.
supposed to divide that by 27 though.
You didn't hear what I just said, did you?
What? What about the truck?
I just told you why. All right, so everybody agrees we got 33 cubic feet of concrete. So I'm gonna erase that. That's our project. So now, here's a formula. We got 3 parts. Got 3 gravel, 2 sand, 1 cement. Okay, how many cubic feet of each of these will we need for this project? It's like saying, just instead of cake, it's gravel. It's gravel and sand. Instead of feet, instead of pounds, it's cubic feet. It doesn't matter what you're dealing with. Gallons, feet, pounds. It's a measurement. Same thing. You already got it?
No,
You stuck?
yeah.
Okay, we'll get you straight. All right, everybody should know the first thing to do. What is the first thing we did on this other one? What did we
Count.
do?
Added
Part.
them,
Added what?
Part
parts of it.
Okay. So how many parts do we have?
6.
We have 6 parts. All right. Very first thing you do. So we got 6 parts here, and there's 6 parts of this. So you look at it like this. There was that slab. I know it's not mixed up like that, but that slab has 1, 2, 3, 4, 5, 6 parts. I said, don't worry about what they are. Remember, a part is a part is a part when you're trying to figure out the count. So if that was 6 part, and this is 33 feet cubed, what did each one of those weigh?
5.5.
How'd you figure that out, Kelsey?
33 divided by 6.
33 divided by 6, okay? That's your parts. What did it equal again, Kelsey?
5.5.
5.5. And it's not pounds this time, it's 5.5 what?
Feet.
Feet
Cubed.
cubed. So that's what a part equals. So we have 6 parts at 5.5 feet cubed. Now that you know how much a part is, you know how much cubic feet's in a part, you can figure these out. This one's easy, right? There's 1 part there. That's what a part equals.
First one's 16.5.
Okay, first one's what?
16.5.
How'd you get that, Nick?
5.5 times 3.
Said 5.5, that's how many part, that's what a part equals. Times 3, 16.5. There's 2 in that one.
11.
Twice of that, right? What is this? 11, right?
11.
Feet cubed. Feet cubed. Write this down. Put this on a card. This is on the first step of the problem. Okay? So now, all right, that's the first part. The second part was kind of like 3 parts. The second part is, now we know, we're going to do this slab. We know how many feet wide of this we got to have. So now we got to figure, we got to get a container. Now, if we had a container that was exactly 1 cubic feet, that we have boxes. They're 1 foot by 1 foot by 1 foot volume. We're not worried, don't get tied up in weight here. People say, well, wait, concrete weighs more, cement might weigh more than the ground. Don't worry about that. It's parts, okay? We're dealing with volume in this issue, cubic feet. So, if we had 1 foot by 1 foot by 1 foot boxes that we'd be putting this in, for this one, how many boxes of that will we need? We need 5.5, because that'd be a cubic feet, because that's what we're dealing with. 5.5 cubic feet. Everybody understand that? And in this one, we'd need 11 boxes of sand, 1 foot boxes, and here we'd need 16.5 boxes. However, we're not going to put them in little boxes. We're going to put them in 5-gallon buckets. So what do you need to know about that bucket?
How many cubic feet in a bucket?
How many cubic feet is in a bucket, okay? Because it might be 2, it might be less than 1. It's probably, I can't remember, it's gonna be more than 1. There might be 2, might be 2.5 in there, so that would change how many buckets you needed. Because if it was 2 buckets, you'd need half the amount that you would need of those boxes. So we have to, next thing, is we have to, and this kind of goes back to your earlier concrete class, y'all should already know this, we went over this last week. You gotta take the bucket, and bucket's usually a smaller top, but I always measure the bottom, about the smaller part where you got a little extra. So we'll say the width of the bucket, you've got to take that bucket, you got to get the diameter of it right, then you got to get the height. Then you're going to get the radius, so you're going to do pi r squared, okay, to get the area of the bucket. Then you're going to multiply that times h, which is the height, and that's going to give you the cubic feet of the bucket. So let's just, for general, and I'm not going to go through all that again. We've already been through that. You should know that, okay? Some basic geometry. If you don't, practice. Now, let's just say that this was, it came out to be 1.6 feet cubed. Means each one of those buckets will hold 1.6 feet of material. And it doesn't matter whether it's gravel, so don't overthink this. Don't think, well, wait, cement packs harder. We're not talking about that. It's volume. That's all figured out by how much we need in terms of the parts. So, if a bucket holds 1.6 feet, let's start with this bottom one down here. And when you do these problems, you can kind of eyeball this a little bit, because you can look at it, because 1.6 feet is about a bucket and a half, isn't it? So we need 5.5 feet. So you can just kind of look at that, our 1.6, that shouldn't be, if you come up with an answer like 45, wait, I'm doing something wrong, okay? So if you needed 5.5 feet of cement and your bucket was 1.6 feet, how do you know how many buckets you need?
Divide that.
You're going to divide this volume by 1.6. And that's your number of buckets.
Like 3 points.
Okay? Same thing. This one, how are we going to get this one? Divided by 1.6. This, divided by 1.6. So how many buckets do we need here?
3.43.
3.43. Okay? How many buckets of sand do we need?
6.87.
A little louder.
6.88.
6.88, outstanding. What about this? How many buckets of gravel? 10.3. All right? Now, you got an idea now what you got to go get, right? And believe it or not, this is actually later, well, for just practicing, I'm going to change this formula up, different parts, and I might even add pozzolan or something. Because remember, if I added another part of something, maybe I said 1 part pozzolan, that's going to change the volume of the parts, because you got to say that divided by 7, because your parts will be a little less. Okay? So you got to remember that. You always got to add your parts up, divide it by your total volume. Okay? Find out how much volume is in a part. Okay? Then multiply your volume by your part, how much volume is in a part, by how many parts you got. Come up with this blue number. Okay? Then get the volume of whatever you're going to be carrying it in, whether it's a 5-gallon bucket or whether it's a 7-yard truck. You got to know what you carry. How many truckloads do I need? How many of this? How many 5-gallon buckets? Okay? Like I said, we're using 5-gallon buckets here to re-answer your question earlier, is we're going to keep this in feet. because this is a hand recipe. This is something we're just doing around the house. We're never gonna need to put this in yards. If you got something you need over a couple of yards, you might just gonna haul, gonna hire a truck. Okay, so we're in buckets. Then we found out how many buckets we got. And if I was gonna do this, I'd round this up to 4, I'd round that up to 7, gonna round that up to 11. Go and fill my buckets up since I'm already down there, you know what I mean? Gonna get that extra bucket. But for this, we're gonna keep them like this. Now the very last step is you need 1 gallon of water per 5-gallon bucket. What I mean by that is your buckets. So how do I figure out how much water I need?
And all the buckets.
Add all that up, somebody do that. What?
20.61.
Not something 4, that's not right. Should be a 4, should be something 4, shouldn't it?
20.61.
Okay, all right, never mind, all right. What?
20.61.
20.61. So 20.61 gallons of water. You're going to bump that up to 21. And believe it or not, that 20.61 gallons of water is enough. Now don't say you're going to mix all this up and pour all that in there, okay? That's actually enough water for you to use and to have left over to clean your tools up with. It's pretty handy, isn't it? Enough to clean your tools up. Now, there ain't tons of it, but enough to clean your butt, clean your shovels, and clean everything up, and clean everything off with. This is called a field expedient concrete method. Learned this in the Army. Yes, sir.
That 20.61, that's the buckets of material added together, isn't it?
Yes, correct.
Do we need to divide that by,
No, just how many buckets of material you need for every 5-gallon buckets total. There's 20-something buckets. If you walked out and if you did all these at one time, you're gonna have 20, actually you might round it up or whatever. However many buckets you see sitting there, if you counted them all up, you counted your buckets of gravel, you counted your buckets of sand, counted your buckets of cement, it came out to be 20.6, that's gonna be, whatever. You'd say, okay, that's how much water I need to bring to the job site. Now this would be something you're doing if, you're building actually when I was doing this, we were like out in places where we had to bring water in. We had to bring 5-gallon buckets of, we had to bring, here you have 5-gallon containers. You need, 4 or 5 of them, 5-gallon bucket, 10-gallon jerry cans or whatever. About 3 of those 10-gallon jerry cans will be enough to do the concrete and do all that up. That's where, you're transporting this all up. If you got to haul water down the shop, you ain't got water down there. All right, I know this is a lot, but what are your questions on this?
I know I got a couple of questions.
All right, you got a couple of questions if you had to think like that. Anybody else while he's thinking? Think you can do one of these if I leave this on the board?
All right. You leave it on the board, I might be.
All right. Make a card. I'm gonna give you one. I got 2 on here. Make a card, and you need to practice this. You'll have one of these on your midterm and on your final exam in this class. Okay, and it'll count 20 points. So make a card. Every time you make a card, make a card and practice doing it with your card. Don't ever depend on, I know you guys got solid memories, but just say, oh yeah, I'll remember that step. Well, something seems a little tricky. Like, you asked that one question, oh, do I divide by that? And when you start doing it, you'll think, oh yeah, I gotta divide this by something else. So, good card. All right, that should be it. Outstanding.